First, let's talk about hormones. So just a brief introduction to hormones. What is the job of the hormones? Well, their main jobs are for growth and differentiation of cells. Think about how cells multiply, go through cellular apoptosis. All of that is influenced by hormones. Their job is to maintain homeostasis, and this is really appropriate for what we're talking about. If you go into a stress response, you go there, but then you come back to homeostasis. And they're also for reproduction. Now, that means not just fertility, it's about reproducing ourselves. We're in a constant state of we break down, we rebuild, we break down, we rebuild. But there's another job there that we want to talk about, and that's the messengers. So hormones are also messengers, and we want to talk about bound versus unbound. Because a hormone that's bound means it's bound to a protein, and therefore it is inactive. It cannot elicit a response from a gland. When a hormone is unbound, also known as the free state of a hormone, which is less than 1% in the body, that hormone, when it interacts with a gland, will elicit a specific response directly correlated to what that hormone is supposed to do. The hormonal stress response. The endocrine system uses a top-down approach to adapt to stressful situations. The hypothalamic pituitary adrenal thyroid gonadal axis is used to describe how the endocrine glands communicate. These are considered the main endocrine glands in this whole system. It starts with the hypothalamus, talks to the pituitary, and downstream to the glands such as the adrenals, the thyroid, the pancreas, and the gonads. Now you'll see in here we also have included the liver. And that's because some of the recent research is considering liver now part of one of the endocrine glands because of its importance with hormone regulation. It's needed for hormone conversion as well as getting rid of excess hormones. And as we go forward, you're going to see how important that is to be able to clear out these excess hormones to keep this regulation going in this whole system, in this endocrine system. There is also some talk about the adipose tissue, the fat cells in the body, could even be considered another endocrine gland because of hormone storage. What we're going to go through is this is all regulated into a feedback. So hormone excess, meaning overproduction, overstorage, can't be cleared, or hormone deficiency can dysregulate this whole system. Stress adaptation and hormone resistance, a process caused by a reduced or absent end organ responsiveness to a biologically active hormone. And we want to look at these three stages. So stage 1 is the alarm stage, can last from minutes to hours. And actually the alarm stage, first stage, is the appropriate response to a stressor. As you can see, when we time it minutes to hours, we're not supposed to stay there. When this happens, hormones are up and or down-regulated to deal with a stress response. For example, acute insulin secretion to regulate a blood sugar spike. Now, stage 2 is starting to get into that resistance phase. This can last from days to weeks. When we stay in this stage, stage 2, hormone receptor sites become desensitized and reduced from high amounts of hormones. Continue with the example of insulin, we can have insulin resistance due to a high sugar diet. Now, stage 3 is exhaustion. This is where someone can be in this stage for months to years. When we get to stage 3, we have hormone receptor sites that have become occupied possibly by exogenous hormones. The receptors are downregulated or damaged. In this more extreme state, we could have insulin resistance and ultimately type 2 diabetes, as well as estrogen dominance, PMS, cortisol resistance, exhaustion, immune system compromise. The list goes on and on. Understanding hormonal feedback loops. Many hormones have feedback mechanisms that control hormone production from correlating glands. Feedback loops become dysregulated when hormone receptor sites become desensitized. Here we are going to give you an example of how that feedback loop works. First, we start with the hypothalamus. In this example, we're using the adrenals. The hypothalamus would then release CRF, or corticotropin releasing factor, to talk to the pituitary. From the pituitary, there's a release of adrenocorticotropic hormone. That will then go downstream to the adrenals to get them to produce more cortisol. As they produce more cortisol, it lets the hypothalamus know that the need is met, and the signal goes down from the hypothalamus and consequently to the pituitary to regulate this tightly controlled system. When it comes to understanding hormonal feedback loops, first we want to understand that it is a tightly controlled system. And almost everything under this endocrine system is in what we call a negative feedback loop. How that works is we have the hypothalamus talking to the pituitary, talking to a downstream gland. When that downstream gland does what it's supposed to do, the signal comes back up because the hormones have been produced to tell the hypothalamus, okay, everything is good. And then the hypothalamus is going to reduce its signal to the pituitary. Otherwise, we have this constant stimulation of more hormones, more hormones, more hormones. So it's a very, very tightly controlled system. The role of nutrition in the stress response. Our endocrine organs use vitamins, minerals, protein, and essential fats to produce and regulate stress-handling hormones. Each gland has an optimal concentration of unique vitamins and minerals that regulate their function, including hormone interaction and hormone receptor site function. Practitioners can recommend a diet and supplement plan that contains adequate amount of vitamins, minerals, essential proteins, and essential fats to support, maintain, and restore the normal function of a dysregulated gland.